Hello and welcome to the Daily Space for today, February 25th, 2019. My name is Dr. Pamela Gay, and I am here to put science in your brains. Now, any of you who tune in for Sunday Science Hour with Annie Wilson or see her when she covers Daily Space on Wednesdays know that she has a dog cam, and she makes it rain Cheerios whenever bits come in. Well, I don't currently have Cheerios, but I had 2 dog bones, so I brought my dogs in. And if we get enough bits, I will go buy a box of Cheerios and make it rain when bits come in the future. But for now, we have noisy bones. So large dog, large dog, large dog. There we go. Large dog is Eddie. Small dog is Stella. They are both Australian Shepherds. So both dogs currently are chewing big old bones because that's what they like. But while we are here, because we all apparently love watching dogs on dog cams, we are also here to cover the news. And that is my phone reminding me to cover the news. Today we have a variety of stories coming to us from past and present, telling us about the origins of, well, our solar system and the life that hopefully we are. In today's first story, I have a tale of a double object. This is, of course, 2014 MU69. It is a bilobate Kuiper belt object that appears to be 2 objects that touched one another, a contact binary, if you will. Now, from this particular angle, it looks like 2 different spheres. But if we were able to rotate this image, we'd see it's actually basically 2 pancakes that have come together very gently and merge together. Now, if you notice in the image, there's a bright neck between the 2 parts of this contact binary. That bright neck is bright because, well, when they contacted one another, a bunch of fresh ice came up and then gathered back around at that neck. So that just is a more reflective area because the ice is a little bit younger. Now, we're still trying to understand exactly what we're seeing in this particular image. If you look closely, well, the closest you can understand is each pixel is about 110 feet or 33 meters across. So the resolution that we have on this object is it's about 66 times worse than the resolution we have when we study the moon. But for a little spacecraft that was trying not to accidentally hit this object, I think it did pretty good. So, yeah, we now have newer high-resolution images. Now, the reason it's taking us so long to get all of these images down is the spacecraft super far away. And if you remember dial-up speeds, this spacecraft is able to communicate with us kind of like early 80s dial-up. So be patient. Things are coming. It will get here eventually. So according to the press release, this processed composite picture combines 9 individual images taken with the long-range reconnaissance imager. This is a LORRI image, each with an exposure time of 0.025 seconds. This image was taken 6.5 minutes before the spacecraft's closest approach to Ultima Thule. The image was taken on January 1st. So, stay tuned. More is yet to come, and hopefully one of these days we'll even have a color understanding of this particular image. Now, Kuiper belt objects like this, we study them because they're what we call pristine sources. They're leftover bits of our early universe. And not our early universe, our early solar system. Places like here on our planet Earth, things have been changed, altered through weathering, chemistry, life. And so when we study our own planet, it's really hard for us to understand what kinds of original bits and pieces went into forming our planet. Kuiper belt objects tell us about the early solar system in the outer parts of the solar system. Asteroids like those being studied by OSIRIS-REx and Hayabusa, which are currently orbiting Bennu and Ryugu, respectively. This tells us about the asteroids that became the building blocks of rocky worlds like our own Earth. Well, trying to understand our own planet Earth requires us to scour the planet for the earliest rocks on Earth. And the earliest rocks on our planet Earth are some of the shale samples that are found in various places in Canada and Australia. And from studying these shale, this isn't shale, this is stromatolites. From studying shale, what we're understanding now is that stromatolites, like those shown in this image, were some of the earliest life forms on Earth to create oxygen. The oxygen that's in our atmosphere is new. It came from life forms. A planet doesn't just get oxygen. Oxygen is one of those things that likes to combine with other atoms. It combines with carbon to make carbon monoxide, carbon dioxide. It'll combine with just about anything. This is why it's called a reactant. This is why oxygen is part of the reason that so many different substances change color when exposed to the air. It's an oxidizing process. Well, since oxygen likes to react with so much, our oxygen would all go away given the opportunity. And the reason we have an oxygen atmosphere is oxygen is constantly being produced by trees, algae, and other life forms on our planet. But the earliest life forms on our planet didn't produce oxygen. They actually produced methane. Thanks for the follow. Why is the sky blue? It's called Rayleigh scattering. The sky is blue because of Rayleigh scattering. So because of life, our atmosphere went from being methane primary, from methanogens, to being primarily oxygen. Trying to understand when and how that happened, though, has been really difficult. Well, new studies of some of this 2.5 billion year old shale has started to show us that it looks like stromatolites like this made the early atmosphere oxygen rich, but first it made the oceans oxygen rich. First made the oceans oxygen rich. Stromatolites are a life form that does a really good imitation of a rock. They sit there working in the shallow waters of the ocean, transferring sunlight into oxygen through a variety of different processes that include taking carbon and turning it into their own body. Shale is able to keep track of changes of what atoms are in the atmosphere, fossilizing them making them into minerals. So by looking at what are the chemicals in shale, we can trace what were the chemicals in the oceans and in the atmosphere. Studies at Arizona State University tell us that it was stromatolites like this that early on, thanks, Rough Smat, that's going to turn into a box of Cheerios that will be much quieter than the current dog bones. Stromatolites like these, this was the first source of life on our planet. And stromatolites like these clearly still exist. So if you're in Australia, don't go hug a stromatolite. Be kind to the ocean life. But imagine that you could give it a hug, and don't, because you actually are grateful that its early atmospheres gave us our oxygen environment. I'm glad to hear, Larry, that the dog bones are quiet to your ears. I can hear them super loud. Okay, so continuing on to our next story of the day. This is NASA-funded research that in my own mind sort of falls into the category of mad science. In NASA-funded research, scientists have been working at the University Medical School in Indianapolis and at the medical school in Ann Arbor, Michigan, to put together artificial DNA. In this case, they created a DNA strand here put together. This is not an actual photo. This is just a computer rendering. There are the normal DNA components, adenosine, cytosine, guanine, and thymine, these are nucleotides. But they also created 4 others that are not actual nucleotides found in nature yet. They haven't created life. They haven't embedded this in life. But the fact that they can now create artificial DNA with, well, man-made nucleotides that don't currently exist in nature, this means that there is the potential with current technologies to start inserting, well, new chemicals into DNA. This is awesome, terrifying, and something that ethicists are going to need to discuss at some point in the future. We may actually be bringing an ethicist onto the show at some point into the future to discuss this and other ways that DNA studies affect what we do and don't know about astrobiology. So, yeah, creepy new things going on in the world of science. So that's what we know for today. We have a new high-resolution image of 2014 MU69. We now understand that the ancient ancestors to stromatolites like this were what first brought oxygen to the deep oceans here on Earth. And scientists are creating DNA out of artificial nucleotides. The world is getting more awesome, more scientific, and we're now getting closer to understanding where we came from and, terrifyingly, to figuring out how to create artificial life. That's all I know, and now I will take your questions. So, type them into the chat. Remember to @ me as @CosmoQuestX, and I will do what I can to answer them. So as a standard station identification, you are watching The Daily Space. We are part of CosmoQuest, your place to learn and do science. We are a production of the Planetary Science Institute, working in collaboration with Youngstown State University. We are made possible through the generous contributions of people like you. We are sustained through your subscriptions, and every bit really matters. Our parent organization, the Planetary Science Institute, is a 501c3 nonprofit dedicated to helping us understand our solar system. So thank you for all that you do, because you make it possible for Annie Wilson and I to come to you live here at CosmoQuest X on Twitch. Give us a follow to, well, join us whenever we go live. Not only do we bring you the Daily Space most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific, that is 6 p.m. London time, we also bring you the Sunday Science Hour and various other launches, landings, and special events from all over astronomy and space science. We are also going to be working to bring you Coding Time, examples of behind the scenes, what's going on with CosmoQuest, and more. This Thursday, we're going to be bringing a special guest onto the show. Following the Daily Space, we are going to be doing an interview with scientist and artist Bill Hartman. He is a space artist who's been, well, giving us the chance to imagine what it would be like to visit other solar systems, to walk on Mars, to, well, stand out in the Kuiper Belt before we had a chance to send New Horizons out to explore for us. He's going to be coming on to talk to us about how it is that he creates such scientifically accurate illustrations and what inspired him to not just study the solar system, but bring it to life with his paintings. So tune in Thursday and be prepared to stay a little bit longer, because not only will we be bringing you the news, but we will be bringing you art. So I'm now going to flip on over and see what all is going on. So, okay, scrolling back through the chat to see what all was asked. So Guido, I'm glad that you liked the Stella and Eddie show. We will be doing the first 4 minutes while the pre-show as dogs from now on. Thank you, Refs Matt, for the bits that will be turned into a Cheerio box. So here we go, scrolling down to see what else is going on. Scrolling for questions. So Hanny asks, if we were able to get a sample of an object so pristine like 2014 MU69, would we be able to tell a lot about the sun's stellar nursery? Yes. I mean, in a perfect world, what we want to do is go out and grab a sample of materials that formed at a whole variety of different distances throughout our solar system. Now, one of the problems that we run into is we don't exactly know where in the solar system different objects formed. And in the early billion years, 2 billion years or so of the solar system, there was a great deal of violence and things kind of got flung around. There was a period up through about 3.5 billion years ago called the Great Heavy Bombardment, during which Saturn and Jupiter may have had orbits that were very different from what they are now, such that Jupiter went around the sun twice for every one time that Saturn went around. This meant that when Saturn and Jupiter were on the same side of the sun on a regular basis, they would fling material all over the place, sending some outwards to leave our solar system, perhaps visiting other solar systems as Oumuamua visited us, or, as we know, coming into the solar system, causing, well, some of the greatest craters in our solar system to be created. This is when many of the giant basins that you can see on the moon were created. It was also during this period that something roughly the size of Mars, that we have named Theia, hit our own early planet Earth, breaking it into a whole bunch of different pieces. The lighter weight stuff formed the moon, the heavier weight stuff formed our Earth. It was a violent time, and it erased our knowledge of exactly where everything formed. Since then, Uranus, Neptune, Saturn, and Jupiter have all migrated to slightly different locations. So what we would need to do is basically get a sample of everything and figure out how to recreate the early solar system by looking at the various isotopic ratios and going, okay, this has this isotopic ratio, that means it started near the sun. This has this isotopic ratio, so it came a little bit later out. And only by basically puzzling out how to create that line of isotopes will we be able to figure out exactly what was the composition of our early solar nebula as a function of distance from the sun. So ideally we want to know just a little bit from each place, but we're pretty much going to have to grab a little bit of everything to put that together. So scrolling. So Astra B. London is saying, as I understand it, the oxygen is always there unless it is changed. Thank you, Crispy Fried Man, for the sub. Thank you so much. Let's light up the chat to celebrate that. So Astra B is asking, as I understand it, the oxygen is always there unless it is changed by nuclear reaction. Is it just combined into other chemical combinations? Yes. So it's molecular oxygen that is not tied to other atoms that isn't always present in an atmosphere. O2, the molecular oxygen you and I are breathing, is only present in an atmosphere for a short while after it's formed, and then it ends up reacting with something else to create rust, to create carbon monoxide, to create carbon dioxide, to create all sorts of different things. And because oxygen is so highly reactive, free radical oxygen, that means it's currently being created. So yes, free oxygen is what I meant. Will leave an atmosphere if it's not constantly being created. So Henny's Ververb goes, could we be able to tell if an exoplanet is habitable for stromatolites? if we look out and we see a world that is within a habitable zone and appears to be very wet, then it would probably be conducive to stromatolites. What we don't know is how to say, oh yeah, that's a stromatolite living on that planet and not just some other form of life. If we see other worlds that have oxygen-rich atmospheres, it means there probably is life of some sort. We just don't know what sort. And as our ability to create artificial DNA implies, you can have DNA that isn't made the way our DNA is. So the solar system may have a lot of stuff very different from what we have here on Earth. So Hanny goes on to ask, oh no, sorry, that was the question I just answered. So scrolling. So Hanny goes on to ask, can the artificial DNA replicate without getting an error? We don't know. So they didn't actually put this artificial DNA into a life form that would have the ability to undergo mitosis and replicate to create new cells, where the DNA was carried forward from one cell to the next. We also haven't inserted it into gametes that have recombined in life forms. I'm kind of okay with that. I'm not sure how I feel right now about the idea of creating life forms with nucleotides that we don't know what proteins they might create. This seems like a really good way to create death. I'm just going to leave it at that. Let's see what else is in here. So Super Cowboy 75 asks, could 2014 MU69 get bigger, or could it separate in the future? Well, this is really a question of, can it undergo another low-speed collision, or will it get hit by something big that causes it to break apart? Impacts are the way that objects like this end up evolving. When you see a contact binary like this one, where it appears to be two objects that touched and merged, the way you get this is through a low-speed impact. The two objects gently gravitationally kiss and come together, chemically bond, and hang out together for the rest of eternity. Now, if instead you have a higher impact, a higher momentum collision, more energy involved in that collision, instead of just gently merging, they're going to break apart. So if a third object comes along and impacts this system, if it impacts it with a low velocity, if it's a low momentum collision, low energy collision, then they can have a chance to chemically bond, become something bigger, no harm, no foul. Now, if instead you have something coming in with a higher velocity, with a higher momentum collision, with more energy, then that energy might be sufficient to break apart the icy bonds holding these two binary pieces together, and it could turn back into multiple objects, perhaps even more than 3 objects. It could be that those pancakes that make up the two parts of 2014 MU69 turn into multiple components. Now, we don't know how often collisions happen in the Kuiper Belt. From all of the research that the New Horizons team has done, searching and searching and searching for objects that New Horizons can visit, it appears that the Kuiper Belt is pretty empty. It has a very low density of materials. Now, that isn't to say that given the fullness of time, there won't be, well, something that crosses the orbit of MU69 and blasts it apart. But this is something that is a low probability of occurring and probably won't happen to any objects within our lifetime, given our current understanding of the density of this material. So scrolling. Let's see, any other questions in here? So Hanny goes on to ask, could life form today, or does the normal DNA have too much of a head start? So we don't know if the formation of life on Earth occurred at a single point, occurred at multiple points. We don't know the probability of life occurring here and on other worlds. we don't know how easy it is for the correct chemicals to come together. And thank you, Nazabar, for the follow. Thank you. We don't know how easy it is for life to form. So I can't answer that question. We just don't have a deep enough understanding to get there from here. So that is what I do know, what I don't know. And these are the doggos who have bones and are very interested in chewing their bones. And I will be coming back tomorrow with Cheerios. So like Annie, I can make it rain when bits are donated. So Astro B is asking, is it true that our early atmosphere was mostly methane and carbon dioxide until photosynthesis got going? Well, we don't know if it was photosynthesis that initially made the oxygen start getting created. What we do know is that early in the Earth's life-having period, there were methanogens that made a methane-rich atmosphere. Now, methane, like oxygen, doesn't hang out in atmospheres unless it's being constantly produced and refurbished. With methane, the problem is sunlight, ultraviolet light, breaks down the methane molecules. So from the fossil record, we know that at one point in the history of the Earth, there was a methane-rich atmosphere. We look at this to say that there must have been early methanogens on our planet. We still periodically do find basically relics of the methanogens. Now, at some point, oxygen-creating microbes, life forms of some sort came into existence. We don't know if life originally started around deep-sea volcanic vents. We don't know if it began on land. We don't know anything other than it created oxygen, and that oxygen was being outproduced from the methane. And the oxygen appears to have been deadly to what was producing the methane. So the oxygen-rich life forms, by being more effective at producing oxygen, killed off the methanogens who couldn't survive in an oxygen-rich environment. It wasn't a dog-eat-dog world. It was a oxygen-creating critter eating a methane-creating critter. We don't know the details, but we do know some of the history. And until we really figure out how life starts, if we can figure out how life starts, I'm not sure we'll know how to answer these questions. So Henny's Warverb asks, is there a way to find out what the atmosphere was before even the methane? It's all a matter of finding super old rocks, and I don't know if we're ever going to find rocks older than the rocks we found already. So it all comes down to what hasn't been recycled into the interior of the earth and is hanging out at the surface where we can find it and process it. So Silvershot 3, the word Genesis just means creating life. It doesn't have to be Bible stuff. It just means that somewhere life started by whatever means possible. People are starting to ask questions and not at me. Let me see if I can catch them as they go by. So Kirov99 asks, what do you think of the idea of abiogenesis on Mars and then coming to Earth? So this is the idea of panspermia. And the idea is that life here might have started out there somewhere among the stars, to quote Battlestar Galactica. And Mars, at one point in history, had a rich ocean. It was covered in water. And we have dog theft going on. And during that early period when Mars had these oceans, it's possible that life there started while we were in the process of trying to recover from the creation of the moon, from that highly destructive event. So we find on the surface of the Earth meteorites that came to us from Mars. These are chunks of rocks that got thrown into outer space when Mars got hit by large asteroids. And if these chunks of rock could travel to Earth, it is possible that if life formed early on Mars, that life could have been carried to Earth and found a niche where it could compete. Now, we don't know how probable that is because we don't know how probable it is that life formed elsewhere. So it's as good a theory as any, given the complete lack of data. And that also raises the question of, is it a matter of some life formed here, some life formed there, they've outcompeted each other? Maybe life is formed just about everywhere, but sometimes it kills each other off. I mean, imagine it is not impossible to imagine a scenario where the early methanogens were actually brought here by Mars, and then the oxygen-creating critters originated here on Earth, outcompeted the methanogens from Mars. All of these things are possible. What we don't know at all is what are the probabilities for one scenario over the other. We don't know. And this is why we do science. We want to know, and we keep exploring in hopes that we can find that fossil life on Mars. We can determine there is no fossil life on Mars, and we can slowly build up more and more accurate understandings of that past that got us to today. Okay, so I'm going to end it on that. Hi, are you a thief? Are you a thief? Is he like laying on one bone while eating the other? I think that's what's happening. So yeah. I think we all love Nightbot here. Our Nightbot is fabulous. Nightbot is fabulous. Okay, so before World War Dog breaks out over here, I am going to remind all of you that the Daily Space is part of CosmoQuest. We are your place to learn and do science. Join us most Mondays through Fridays at 1 p.m. Eastern, 6 p.m. London time. That is 10 a.m. Pacific. And we will bring you the newest information we have from astronomy and space science. Tune in Sundays, same time, same place for the Sunday Science Hour with Annie Wilson. And give us a follow to find out all those times that we randomly go live to bring you launches, landings, and other special events, and sometimes just a behind-the-scenes view at what is going on with CosmoQuest. We are here thanks to the generous contributions of people like you. Thank you for all that you give, and thank you for making this show possible. And that's all she wrote. I am going to find some place to raid, and thank you all so much for being here. Let's see who is live, and the place that I go to look is the Knowledge Fellowship. I'm looking to see what other science streamers are out there. So we have, we have Jesse Skinner appears to be live, asking how many caches would an offline PWA cache if an offline PWA could cache caches? And I think he's going to get a raid simply for having that amusing of a title. Let's see if he's still going. And I will dig the bone out from underneath Eddie to make sure they both have a bone as soon as I go off. So thank you all for being here. And the next time we go live will probably be me after I ate lunch, doing a little bit of coding to show you how we chop up images that we share here on CosmoQuest. So, yeah, that's all she wrote. Wherever you are in the world, have a fabulous morning, evening, afternoon, and if the weather lets you, get outside and look up. Bye-bye.